All right, hello again, B and Alex. Today we are going to get into taking the integrals of the trig functions. So you'll probably notice that these are the derivatives backwards, but that's okay. That's what the list is made of. So we're just literally undoing the derivatives. So our first integral would be the integral of cosine. Now, if you remember, the derivative of sine, actually let me throw a dx on here so we can be proper. If you remember, the derivative of sine is cosine, and then the derivative of cosine is negative sine. So these first two are just going to literally be that undone. So the integral of cosine will be sine of x, and don't forget about your plus c. Okay, so remember, the derivative of sine ended up being cosine, so if we have cosine, the integral would be going back to sine. So the next one, the integral of sine x. Okay, think back about what you would have to do, what you would have to take the derivative of to get sine x, and that would be taking the derivative of cosine x. So cosine x, the derivative of that would be negative sine x, but we have regular sine x, so we can say that that is negative cosine x plus c. Our third one, let's say that we have to integrate secant squared x. Okay, so that would end up being tangent x, because if you remember, taking the derivative of tangent outputs you a secant squared. Next on the list, we will have the the integral of secant x tangent x. Okay, hang on, I forgot my dx. So taking the derivative of secant x would have outputted you secant tangent, so therefore this just gives us secant x plus c. I got two more. Next one on the list is cosecant squared x. And if you remember, if you take the derivative of cotangent, that's negative cosecant squared. So we need to say that this is negative cotangent x plus c. And then my third and last, or sixth and last one is cosecant x cotangent x, which if you remember that, if you take the derivative of cosecant, it gives you negative cosecant cotangent, so we would have to have negative cosecant x plus c. So those are our six. Again, you've got the integral of cosine x is sine x plus c. The integral of sine x is negative cosine x plus c. The integral of secant squared x is tangent x plus c. The integral of secant x tangent x is regular secant x. The integral of cosecant squared x is going to be negative cotangent x plus c. And then lastly, the integral of cosecant cotangent dx is negative cosecant x plus c. So those are our six formulas. This is very similar to deriving whenever we just used those six formulas in a couple examples. And that's basically how this is going to roll. So example one here, for instance, if I wanted to integrate 2 sine of x. Now we talked about it a little bit ago, yesterday, sorry. We talked about it yesterday that 2 is really just along for the ride on this. It's very similar to deriving. This was the third rule that we would have had yesterday. 2 can really just sit out front. So what we're really doing here is taking 2, the integral of sine x dx. And then it's very simple from here because we know how to integrate sine x, because it's right here at the top of the screen. Sine x dx is equal to negative cosine x. So I still have the 2 out front, but then that's multiplied by the integral of sine x is negative cosine x. Okay, so that really turns into negative 2 cosine x, and then don't forget about the plus c. So that is what that integral equals. Now, sometimes you'll have to rearrange these integrals before you start them. For example, over here on example 2, we don't know how to do anything like this right now. We don't know how to do any kind of product rule or anything like that like we had in deriving. So right now, our best option is to just distribute before we start. So this is still the integral of cosecant times cosecant would be cosecant squared x. And then I've got cosecant times cotangent, which would be cosecant x cotangent x. Okay, this is still all dx. Okay, this has a little dx too. So one of the rules that we also talked about yesterday was how you can split these. So this is really the integral of cosecant squared x dx plus the integral of cosecant x cotangent x dx. All right, so then I've got to look back up here at my list and see what the heck is the integral of cosecant squared. And I can see it's the fifth one down there. It is negative cotangent x. So this whole first part turns into negative cotangent x. Then I've got the second part, cosecant cotangent, which happens to be the bottom one right here. The integral of cosecant cotangent is negative cosecant x. So I've got to do minus cosecant x, and then I can't forget about putting my plus c. So that is what that integral works out to be. Okay, so this really is not all that tough as long as you can visualize just going backwards from the derivatives like we used to do. So you should be okay with it. This is a little bit, not really a challenge or anything like that, but it is, it's tough on the mind to think about and understand the going backwards and forwards and stuff like that. So I've got a set of problems for you. If we're going to work on page 287 again, we're going to do 23 through 28. These are the ones that exclusively have to do with the trig problems, and then we will do a few more on that section tomorrow as well. Okay, so let me know if you got any questions. Other than that, good luck with this.